Hello, everyone. Today's seminar lesson, we're going to go through some example of basic trigonometric equations. Okay. So I'm going to go through two basic trigonometric equation types. So the first type is with restricted domain, and the second type is with unrestricted domain. Okay, so with the restricted domain, it's given that theta is between 0 and 2 pi. Let me highlight that. Theta is between 0 and 2 pi. And first problem, we want to solve tangent theta squared equal 1/3. Right? So the first thing I do is I will square root both sides. Square root both sides. When you square root both sides, don't forget to add plus and minus. So I have tangent theta equal plus minus 1 over square root of 3. Right. If you want to rationalize this, you can write it at plus minus root 3 over 3. But I think I'm going to keep 1 over square root of 3, okay? Because it's easier for me to look up on the unit circle. So we have two cases here. We have either tangent theta is equal to positive 1 over root 3, or tangent theta is equal to negative 1 over square root of 3. Okay, so if you look at a unit circle, tangent theta is equal to 1 over square root of 3 because tangent theta is positive. So we're going to look at quadrant 1 and quadrant 3, right? So when you look it up, you see that theta is equal to pi over 6 and 7 pi over 6. Right? The two angle give you tangent of 1 over square root of 3. And when we look at the negative case, tangent theta equal negative 1 over root 3, we see that theta is equal to 5 pi over 6 and 11 pi over 6. So these are our answers. Okay. Problem B, cosine theta plus 1 equals 0. So first thing first, I'm going to move the 1 to the left, it's the right hand side. So if I subtract 1 both sides, that's canceled, right? So I have cosine theta, excuse me, equal negative 1. And if you look at the unit circle from 0 to 2 pi, cosine of theta equal to negative 1 when theta equal to pi, right? Equal to pi. So that will be the only our answer. Okay. All right. So the next the next problems we're going to look at a trigonometric equation with unrestricted domain. Remark, for every solution in that period, add a multiple of that period to get the general solution. So if you remember, the period of sine, cosine, secant, and cosecant is 2k pi, right? Where k is just the integers, and the period of tangent, cotangent function is k pi. Again, k is integers. So at the end of your answer, you want to add 2k pi if it's sine, cosine, secant, or cosecant, and you want to add k pi if it's tangent or cotangent. Okay, so let's take a look at the first problem. I have 2 cosine square x minus 7 cosine x plus 3 equals 0. So if you look closely for this equation, it is a quadratic equation, right? Because we have a square term, and then the first degree, and then the constant. So if it's uneasy for you to factor in this form, in the cosine form, you may wanna let y equal cosine x. And maybe it's easier for you to see to use substitution. So this implies y squared cosine equal cosine square x. right? And then instead of writing the equation in terms of cosine, I'm going to write it in terms of y, right? So this equation becomes 2y squared minus 7y plus 3 equals 0. And I believe this is factorable. It is factorable. So we're going to factor it. Okay. So it's gonna be, let's see, I need two number multiply, give me 3, and add up to get me -7. First of all, I need 2y here and a y here because 2y times y is 2y squared. And maybe a -1 and -3. Now let's see. Let's check. You can always check. So I have -y for the inner product and -6y for the outer product. So add up into -7y. So we're good. Right. So we're good. Okay. Okay. So we have either y is equal to 1/2 or y equal to 3. Right? But remember, we're not solving y, right? We're solving x. So we have to plug the cosine term back. So remember, we let y equal cosine x, right? So I'm gonna, instead of y, I'm gonna write it as cosine x equal 1/2. And over here, I have cosine x equal 3. For the left case, if you look up on unit circle, cosine of x equal 1/2 when x equal pi over 3, or x equal 5 pi over 3. Right, and remember, and don't forget, remember what we talk about here, because this is unrestricted domain type of equation. So you want to add 2k pi, right, because it's cosine function. So at the end, I want to add 2k pi, and then same thing down for down here, 2k pi. Okay. All right. So these are our solution for the left case. Right. Now, cosine of x equal 3. This one you cannot look up on the unit circle. So in order to solve for x, we're going to use the inverse function. Right. So what I'm going to do is I'm going to take inverse function both sides. Let me move this 3 to the right a little bit so I can add cosine inverse. But remember, before you do this, you need to check the domain of the inverse function. So recall. Let me do a little recall. Recall that the domain of cosine inverse is between -1 and 1. Right. However, here we have 3. The input is 3. So it is not 3. Remember, 3 is not 3. It is not belong to the interval -1 and 1 to 1, right? So therefore we cannot continue, right? So that means no solution. No solution for that case. Okay. So the only solution we have is this one and this one. Okay, move on to the second problem. Problem B. Problem B. We have 5 sine x cosine x plus 2 cosine x equals 0. So here I see a common factor. I see cosine x and cosine x, right? So I'm going to factor that out. Cosine x. And what's left in the first term is 5 sine x. And then what's left in the second term is just 2 equal to 0. And this imply either cosine x equals 0 or 5 sine x plus 2 equals 0. Okay, so cosine of x equals 0 when x equal pi half, or x equal 3 pi half, right? And again, because it's a cosine function, we're going to add 2k pi at the end plus 2k pi. Okay, so these are our solution. Okay, so for the second case, for the right hand side, I have 5 sine x plus 2 equals 0. So that means, so this implies sine x equal negative 2/5, right? You subtract 2, divide both sides by 5. You got sine of x equal negative 2/5. Again, you cannot look this up on a unit circle, so we're going to use inverse function. Move this one to the right a little bit. Okay, so now I'm going to add sine inverse to both sides. Sine inverse, sine inverse. Oops, sorry. Sine inverse. Okay. All right. Again, the domain of sine inverse is between -1 and 1. So negative 2/5 is certainly between -1 and 1. So in this case, we can continue to solve this equation, right? So in this case, I can cancel sine and sine inverse. Right? So what's left is just x equal to sine inverse of negative 2/5. Okay, so remember the range of sine inverse is quadrant 1 and quadrant 4, right? From negative pi half to pi half. So if you draw this out, so maybe let me draw this out. Like that. Okay, and then negative 2/5, maybe negative 2/5, maybe right here. That's negative 2/5. Okay. And then we want size of negative 2/5. Side is y, right? Side of the y-axis. So let's see. So is so x equals sine inverse of negative 2/5. So one angle, if you plug this in on the calculator, so let's plug this in on the calculator and see. Clear. So I have let me check my mode. It has to be in radian, which is. So that's good. So I have sine inverse of negative 2/5 is roughly negative 0.4. 0.41. So this one, if you plug it in, it'll give you roughly a negative 0.41. Okay, so that's one of them. And then don't forget to add plus 2k pi. Okay, so that's one of the answer. So that's one of the answer. Okay. Now, negative 0.41, that is this one right here. Maybe I'll highlight it in green. Okay. Is this one right here. That's angle right there. I know a little small, you can see. What about the other one? What about this one? What about the one? What about that one? Right? But we know that this green, this green angle is equal to this green angle, right? So in order to figure out the yellow angles, all we have to do is we take what? Pi plus 0.41, right? Which is roughly pi is 3.14 plus 0.41 is roughly 3.55. And again, don't forget to plus 2k pi. 2k pi. So that is our second angle. This one a little bit stink. It's a little stink. Yeah, you gotta be careful for this one. Okay. All right. Okay, so that is how you solve basic trigonometric function or equation with unrestricted domain type. Okay, thank you for watching.